Hello. Today we're going to discuss the part 1 of chapter 5, which deals with quasi-experimental designs with control groups and pretest. So let's start. So what are the benefits of having control groups and pretest in a quasi-experimental design? So carefully selected comparison groups with pretest measures on the same variable as the post-test facilitates causal inferencing, and that's why they are important in a quasi-experiment. The benefits, as discussed in the book, are first, we get to know how the groups initially differ so as to determine which internal validity threat or threats would be more plausible. Second benefit is we learn the magnitude of initial group differences on the variable that is highly correlated with the outcome. And third and final benefit discussed in the book is that the pretest help with statistical analysis if the reliability of these pretest measures is known. So, untreated control group designs with dependent pretest and post-test samples is considered most common of all quasi-experiments. As the diagram shows, uh, there is a treatment group and an untreated comparison group. This design uses non-equivalent comparison groups. They are called non-equivalent because if you would recall, in a random or in a gold standard experiment, randomized experiment, the samples for the treatment and the control group are taken from the population randomly. So that in that respect, they are similar, considered equivalent groups. Whereas in a quasi experiment, because they are not selected randomly, they are non-equivalent groups. So this design uses non-equivalent comparison group, hence is also termed non-equivalent design. As the pretest and the post-test data are gathered on the same units in each group, the design includes the term dependent. That's why it's called the untreated control group design with dependent pretest and post-test samples. Now, use of a pretest and a comparison group uh, helps detect the following validity threats. One, selection bias, which is expected to be present due to the non-equivalent groups being used in the design as we just discussed. Pretest allows exploration of the size and direction of the bias, and it is important to note, however, that detection of any selection bias during a pretest is dependent upon the size of the bias. Absence of pretest differences in a quasi-experiment does not mean that selection bias is absent. Attrition is the second threat. Pretest also allows examination of the nature of attrition by analyzing group differences between those who remain in the study and those who leave the study. In presence of group differences, it should be expected that the selection bias that is possibly present is associated with other threats, either additively or interactively. As we have noted in chapter 2 under threats, it is the 9 type of internal validity threat. These combined threats, the interactive or additive threats, may manifest as one selection maturation, which is the third type of overall threat that we are discussing, which is born out of non-equivalence of the groups. So a pretest difference between the groups is further enhanced at the post-test due to the probability of the treatment group to score more rather than the treatment effect. The fourth overall threat is selection instrumentation threat, which can occur when there are these non-equivalent groups begin at different points on the pretest. We know that scales on any test instrument are not uniform at each level. So any discordance between the between the groups regarding initiation of the pretest will reflect on the group differences observed later at the post-test. So any such post-test differences would be due to A, size of the initial non-equivalence between the groups, B, magnitude of pre-test post-test change, and C, the proximity of any group difference to the end of the scale. At what point on scale these differences lie or these tests lie will also make a difference. Examination of frequency distributions within each group helps identify such problems by determining the covariance between group means and variances. The fifth overall threat is selection regression threat. It can occur if the groups have been selected from completely different populations. The solution is to use matched controls based on certain static characteristics. The sixth and final threat that can occur is selection history, and it is a possibility when an unforeseen event has occurred between the pre-test and the post-test, and which is affecting one group differently or more than the other. Such event can be a confounding factor, or it can, in terms of a program, it can be a program with similar outcome as the outcome effects as the treatment effect. Let's move to the next slide. So, the textbook discusses a few design elements that are typically used to strengthen quasi-experimental designs by reducing the number of plausibility of internal validity threats. The book very smartly defines that quasi-experiments are actually nothing but a combination of such design elements which are used to reduce internal validity threats based on the context of the research. So certain validity threats will be more focused on than the others based on the research context. So these elements have been categorized by the book into four main groups: assignment, measurement, comparison groups, and treatment. Now each of these are further divided into subgroups as listed on the slides. Just touch upon them quickly. Assignment is divided into random assignment, cutoff based assignment, other non-random assignment, matching and stratifying, and masking. Measurement is divided into four main subgroups: post-test observations, pre-test observations, moderator variable with predicted interactions, and measuring threats to validity. Post-test observations are further grouped into single post-test, non-equivalent dependent variables, and multiple substantive post-tests. Pre-test observations are also grouped into single pretest, retrospective pretests, proxy pretests, repeated pretests over time, and pretests on independent samples. The third design element is comparison group, which is further divided into single non-equivalent groups, multiple non-equivalent groups, cohorts, internal versus external controls, and constructed contrasts. Constructed contrasts are further categorized into regression extrapolation contrasts, normed contrasts, and secondary data contrasts. The fourth design element of treatment is grouped into switching replications, reverse treatments, removed treatments, and repeated treatments. It is not possible to look at each and every subgroup and further subgroups in detail. So let us discuss these four broader categories uh, briefly. So the assignment. Assignment in a quasi-experiment is not under the researcher's control, as we know. And different subgroups that we saw, they help avoid self-selection, uh, reduce investigator and participant reactivity, help approximate random assignment, and increase group similarity. In case of the measurement element design, through all the 12 different subgroups that we just listed on the slide, they ensure temporal precedence of cause and effect, strengthen the assignment of effect to the treatment, examine patterns of effects to confirm a priori knowledge, examine selection bias and attrition, reveal maturational trends, detect any regression to mean, regression artifact, study testing and instrumentation effects, and confirming treatment effects. These are the benefits of this particular design of measurement. What does, how does the comparison group element help? It helps determine the counterfactual, which is the most important aspect as we have seen during the initiation of quasi-experimental design study. So allows exploration of additional threats and narrow them down, helps compare actual and projected post-test scores, enables comparison with normed samples and those from other studies. The fourth element, the treatment design, helps the researcher in strengthening causal inference by controlling scheduling of treatment administration. So these are the salient features of all these design elements. Let's move to the next slide. Now, the book has a statement: possible threats to validity are not always plausible ones. So, what does that mean? So, if you remember, we discussed in chapter 2 that there are 9 possible threats to internal validity. But the probability, that is the plausibility, of any of these 9 threats actually occurring depends upon certain contextual conditions. A. Joint characteristics of the design. B. Extra study or pre-existing knowledge about the threats. And C. Pattern of observed study results. Hence, the statement possible threats of to validity are not always plausible. They become plausible if any of these conditions are present. So let us now look at 5 outcome patterns that are observed in pre-test and post-test comparison group designs from the lens of selection maturation. We have pasted the slides, the charts for each of these outcomes. There are 5 outcomes to help better understand each outcome. So the first outcome is both groups grow apart in the same direction, albeit at different average rates. This pattern is termed as fan sprayed model of maturation. Of course, standardization of the scores across groups will make the fan sprayed disappear. If such differences between groups is due to selection maturation, then within group differences may also be seen and should be checked for. Selection maturation threat is often associated with post-test within group variances, which are greater than corresponding pre-test within group variances. Such analysis can help determine whether these effects are due to the treatment or any other cause. This fan sprayed model outcome, it seems, is a commonplace in quasi-experimental studies. The second outcome in the chart is no change in the control group. This is a relatively unreliable model of differential change and is indicative of the presence of a selection maturation threat, unless the change in the treatment continues unabated in the long run. So this is it is not usually found, but the selection maturation threat is not considered if the effect on the treatment is continues over a long period. Now, the third outcome is a situation where initial pre-test and differential favor of the treatment group diminishes over time. So, as the title suggests, and if you can see in the chart, the pre-test performance is higher for the treatment group initially at the pre-test, and as at the post-test, the effect performance is either reduced or completely eliminated. Here it is seen as reduced. So although selection maturation threat is less plausible in this case, other internal validity threats may occur. The fourth outcome, as the book describes, is the same situation as we saw in the previous case, but it is with respect to the control group. So any high performance of the control group at pre-test is reduced or vanishes at the post-test. This outcome is subject to selection maturation and selection history threat. Such cases beg the need for assessing pre-test differences more carefully, including the presence and reasons for any selection bias, which may be the cause for such high performance either for the treatment or the control group at the beginning. The selection maturation threat has to be carefully determined, therefore, and these outcomes are actually help, these outcomes do help in causal interpretation, but after careful consideration of any or ruling out any selection bias at the pretest. The fourth outcome, the fifth outcome the book talks about is uh, when the scores for both groups move in one direction. If you see in the last chart at the bottom right, uh, the fourth, the fifth outcome is the treatment and control group scores are moving in one direction from the pretest, and then at certain point they cross each other and then move in the opposite directions. This book postulates that this outcome is particularly prone to causal interpretation, such type of outcome. The plausibility of selection maturation threat is reduced. This outcome renders a regression threat unlikely, so it is more plausible to causal inferencing. Such outcome is very difficult to actualize in real life, as usually the power required to detect any interaction is is low and very difficult to actually uh, identify the significance statistically. The book suggests that instead of aiming for such an outcome, which is very difficult to achieve, researchers should add stronger design controls to the basic pretest post-test design with control group. Let's move to the next slide. Now, how do we improve untreated control group design with pre-test and post-test samples? Because we saw a lot of gaps in this design. So the book describes that any improvement for the untreated control group design with pre-test and post-test samples should revolve around designing study features to address any threat of validity. So the main focus should be addressing any threats to validity. The book describes four approaches to achieve this. First is using a double pretest. Have two, so we have inserted some charts to help understand these concepts. So if you look at the chart, two pretests are administered at different time points, preferably with the same gap as between the second pretest and post-test, as shown in the chart. This feature helps tease out treatment-like effects, if any, due to any other confounder or mediator variable between the two pretests. This is confirmed if effect similar to that from O2 to O3 is observed between O1 and O2. Selection maturation threat can be assessed assuming that changes between O1 and O2 will continue between O2 and O2, especially in the case of the control variable. Although not perfect, it can help identify any regression effect between O1 and O2. The second chart and second outcome is using a second way to improve is using switching replications, where as seen in the chart, pretest is given to both groups and treatment is administered to one group and post-test is done on both the groups, control and treatment. Then, as a third step, treatment is administered to the control group and not the group treated earlier. And second post-test is done on both groups. However, the treatments are, though they are administered to both the groups, they are contextually and historically supposed to be different. So, the treatment introduction is considered the treatment reintroduction, the second treatment introduction to the second group is considered a modified replication. This helps identify internal and external validity issues by probing any changes in treatment effect between these two groups. This design can be extended to a study involving many groups, incorporating randomization, which can strengthen causal inferencing. The design is strong as only limited alternative explanations are available for these different treatment effects. However, there are two limitations noted in this design. One is lingering treatment effect in the first group, presumably in the same direction as the treatment effect for the second group, will confuse the uh, conclusion. And second limitation is compensatory rivalry threat due to withdrawal of treatment from one group and then introduction in the second. This may occur. The third way approach is using a reversed treatment control group. As seen in the diagram, this design revolves around concept of opposing treatment effects. So, in the upper line, treatment X1 produces effect in one direction and X minus in the lower line in the reverse direction as compared to X plus. This design is supposed to have a specific construct validity advantage. The causal construct, however, has to be carefully elaborated to ensure sensitivity to measuring effects in both directions. There has to be reliability in measurement of effects in both the directions, otherwise, this design will hold no value. Both selection history and selection maturation threats are reduced. However, this design is difficult to implement as it is not practical and also may border on unethical and harmful, reversing the treatment effect or giving any opposite or negative treatment to any group or individuals. The fourth approach the book talks about is improvement for improvement is direct measurement of threats to validity. There is no chart for this because this is just a concept or just an approach. There is researchers sometimes fall in the trap of for whatever time sensitivity and for the urgency of getting the study out or finalizing the study. So if they have control for one internal validity or any validity threat, then it is usually considered that other validity threats will also be minimized or eliminated. Now, this should be avoided, and each plausible threat. There are possible threats, but one has to know the plausible threats by through a priori knowledge or through other evidence and through certain analysis at the start of the study. So, having an understanding of all the plausible threats, it is important that each is identified, analyzed, and as much as possible reduced or eliminated. So, this then helps not only for the study validity but also in subsequent statistical analysis and interpretation of the effects. So, this is part one of this aspect of quasi experimental design. Till next week, thank you.